Hello everyone, welcome to the session about picking the right API for the right job. I think people are still coming in, but let's get started. Also welcome for those watching us remotely. So, my name is Nitschinger, and even if you can't tell because of the nice contrast over there, but you see me here anyways, right? My name is Nitschinger. I work as a senior software engineer on the SDK team. And I'm from Austria, the home of Schnitzel, and also the Sound of Music. But I have to admit, I never saw Sound of Music before, which is probably a surprise to most people. And I don't wear anything like this in my private time, so I'm sorry, I don't even own anything like that. So, anyways, so let's get started. At this conference, you've probably heard a lot about like all the different services that we have. Keyvalue, analytics, full text search, Fuse, Nickel, all these kinds of APIs, right? And the capabilities that the server provide. But if we can't use them from our favorite programming language, right? Be it Java, .NET, whatever you want to use, it's pretty useless, right? Because you don't want to fire up curl to do a Nickel query in a production system. That's probably not going to happen, right? So in this talk, I want to give you a little more insight into what are the right APIs and abstractions to use from an SDK point of view, how you can take this from like prototyping in CPQ and writing Nickel queries to actually taking it to like Java, .NET, and so forth, getting it production ready. So basically, how we can get one SDK API that abstracts over all our services to rule them all, right? And Colin would agree probably, we need something. So you've probably seen that kind of picture before, right? So here we have classical MDS scenario where we have a 6-node cluster, and each node in the cluster runs different services. So for example, one might run the data service, one might have an indexing service enabled, the other might be doing full text search or Nickel querying, right? But one of the things if we take this apart a little bit, right? Let's not consider like what the cluster manager is and how we actually do the operational deployment. What you can see here on the top is actually, so we have our application servers, right? Which need to talk to the different services on the different nodes in a transparent way, because we don't want you to know, okay, my application knows that the query engine is on node 3 in my cluster, so I need to make sure that I always go to this node to do the specific query, right? That's neither useful nor not very nice from an API point of view. So if we take apart all the other components of our server, right? So it comes down to, we have right now basically 5 different services that we are exposing from the SDKs and that you want to consume from your application, right? So we have data, that's Keyvalue, we have Fuse, we have Nickel, we have full text search, and now recently announced today at this conference, analytics. Now, you've seen all the nice things that you can do with them, but what no one told you probably is that under the covers, the picture isn't as shiny, right? And what I mean by that is that all the different services internally, right? So for example, the Keyvalue runs on port 11210 and exposes a binary protocol. Fuse runs on port 8092 and has a specific JSON schema, right? Nickel runs on port 8093 and has a different JSON schema, right? And then the same for full text search and analytics. So all of those responses look completely different. They have a different structure, right? Sometimes, like with Keyvalue and binary data, they even have a different format, which is probably not even easy to read. So we don't want you to deal with all of that, right? So this is why I have a job, right? I want to abstract this away from you and make it as easy and as possible to use. Now, naturally, if we go from our server-side services to the client-side, we have a problem. Because as Gollum likes the one ring to rule them all, one of the tensions that we get when we're implementing those SDKs is that we always need to balance language specifics, right, with uniformity across SDKs. Now, if you only work in one language all the time, you probably favor language specifics, right? So if you use, let's say, I don't know, if you use our Java SDK with all those Rx Java specifics, or you want to use Java 8 streams and all the new things, right, the new shiny things, you don't really care about uniformity. But if you're working in an environment where you have Java and .NET applications in one system, you pretty much care about uniformity because you don't want to start with Java and then go to .NET and relearn everything, right? That's not really a good idea. So we need, from the SDK side, we need to balance those two things. We need to make sure that you still get all the nice features in your language, but make sure that if you switch languages, you switch SDKs, you still feel at home, right? But there's a tension there. Now, another thing that we need to balance is that abstract concept, but also we have many different SDK APIs, right? So we provide support in PHP, Go, Python, Java, .NET, and Node.js as official SDKs. And if you look at that, right, there are statically typed languages. We have languages without like a real type system, right? Some of them are even more dynamic, right? So all of them have different ways to program with them, right? You program a Node.js application radically different than you would do with a classic Java application, right? So how can we make that work? So that's one of the aspects in the SDK. And the other problem is that, like in every company, right, on the SDK team, we have different people. And everyone has different favorites, right? Some would like one specific approach to develop applications, and others might not agree. So we always have this tension in our SDK team. We do something for Java, but then we figure out, that doesn't work for Node, and then Go comes along and completely blows everything apart that we did in a proof of concept. So there's lots of stuff going on there. Now, if we can't agree what we do in our team, then we have our PM who spoke before in that room, right? So Tyler. And if even he can't figure it out, then we have Matt. So he's our boss, and he gets he's the evil one to basically rule us all. He's sitting here, so you can ask him later. But normally he doesn't have to do the rule there. So okay. Now on a more serious note, one thing I quickly wanted to mention before we go into code is that one way to achieve this is that we established an RFC process for the SDK team where we can have a semi-formal process where one person of the team basically picks an SDK and shepherds a new, let's say, new functionality. Imagine the new analytics system. So someone would try to do a proof of concept and then figure out how to get this into an RFC specification, and then we would implement it in all of the other SDKs to identify inconsistencies, and then we move forward and iterate until we get to a point where we're all satisfied, right? What we really want to avoid is that we ship something, and then 2 months later someone says, oh, wait a minute, in Java I can do this, but in .NET it doesn't work, right? So this is the worst case, which we really want to avoid. Now, why I mentioned this here is that this is open source, right? So this is on GitHub, and you can participate in those RFCs. You can even create your own ones, right? If you want to see specific functionality in the SDKs that we don't currently provide, you can provide RFCs, right? So you can start one, and then we'll work with you and basically get it done, right? So this is open and common and all done in public, so there's nothing to hide there. So one example how we prioritize uniformity is that in the general program flow. So it doesn't matter if you program in Node.js, Java, or Go, the general program flow with the SDK from an API perspective is always the same. So in every SDK, you'll get some kind of reference to a cluster object, and then you open buckets from there. And then you operate on your bucket, and then you perform your operations like a key value, get and set, and so forth, right? So here you see opening a bucket, so connecting to a cluster and opening a bucket for 3 different versions. So on the top, we see Node.js, where we basically here use the cluster object to create a new cluster and then call open bucket on it. And it looks very similar in Java and Go. And what I'm going to show here today, it looks easy and nice on the screen, but it's actually, if you don't have to think about all of that, then we did our job right? Because if you don't get any surprises and it looks the same all the way, then we did a good job in figuring out what you want to do actually out there. Now, here's another way, like how we can prioritize uniformity. So here we are performing a key value upsert, right? So we are inserting a document via our key value protocol into the database, right? And here again, you see Node.js, Java, and Go. And while there are small differences, like for example, in Go, the upsert starts with an uppercase A because that's their notation, that's fine, right? But you can see that you always create some kind of document structure, you always have a document ID, and then, for example, in Node.js here, there is a callback which says function. We're not doing anything here, but in Node.js, you would then work asynchronously with a callback. In Java here, this is a synchronous example. You would just get a response code, right? And in Go looks very similar. So these are the cases where we really try to make it as similar as possible. So where do we prioritize language specific, for example? In Couchbase Server 4.5, we added an API for SubDocument. So Couchbase Server 4.5 supports SubDocument operations. And for example, in Python, compared to Java. In Java, what we ended up doing is like using a builder API, right? So if you're developing Java, constructing objects with basically chaining methods together with a builder pattern is very naturally. But it turns out in Python, no one does that, right? So we wouldn't want to impose that to a Python developer. So what we did there is that you can see there is lookup in. The lookup in method on the bucket is the same. So again, uniformity. But then we're not using some kind of builder structure. But here, what you can see is that in Python, you chain in those parameters as dynamic lists. That's the way you do it in Python, right? It still looks similar, but it's a little different. And this is where we kind of make those small trade-offs to still make sure you feel at home in your language without throwing all the uniformity overboard. All right, so let's go into the meat of the talk. Let's talk about how we can navigate the API landscape and Couchbase Server from an SDK point of view. Let's go through all of the services and talk about the strengths and weaknesses of each other. So, Keyvalue, right? That's the bread and butter of Couchbase, which has been there since the very beginning. Now, at the very top, you always see my subjective marker between low latency and high flexibility, right? And the ring you see there will go from left to right depending on where we are on the APIs, right? So if you're working with Keyvalue APIs, it's hands down the most fastest way to access documents and mutate them, right? There is no fast approach because it's literally we're taking the document ID, hashing it, figuring out where to go and go straight to the node, right? There is no indirection involved, no query planner, no indexing access, right? So if you know the document ID, use Keyvalue, right? Hands down. But of course, it comes with a lack of flexibility because you always need to know the document ID, otherwise you can't access the value. So that's the trade-off here. Also what's there is that the Keyvalue protocol has a very efficient binary protocol underneath that we abstract away from you, but it provides us, again, low latency, high throughput because it's more efficient than encoding JSON and decoding it. Again, since Server 4.5, it also includes SubDocument manipulation, which cuts down even more network traffic. So here's an example in Node.js how you can do Keyvalue access. Very similar to the slide that we've seen before. Here we do an insert. Now, insert is similar to upsert. The only difference is that if you do an upsert, it will always override a document which would already exist. In the insert case, it would fail saying the document does not exist, right? So here we give it a document ID and then some value. And this is where you can see, like, here's the language-specific part of Node.js. Node.js is very good in dealing with JSON naturally, right? So you can give it a native JSON object, like some value, and it will turn it into JSON document on the server side. If you're coming from Java, then you need to create a JSON object of this type and then do more work with it, right? And then we have a callback, which once the document is inserted, we check if there's an error. If not, we print out the value. Here's another example where we load a document, again, Node.js here, so we call bucket.get, we give it the document ID, and then as a callback, we get the full document back if it exists. If it doesn't exist, we get this key not found error here in Node.js, and then we do something with it. So how can we do SubDocument access, for example, in .NET? Well, there are two ways to do it. So if you want to load parts of your SubDocument, you would use the lookupin method on your bucket. If you want to mutate parts of your document, you would use mutedin. And here we see a builder pattern because in .NET, that's also the way you do this kind of things, like similar to Java. So you would call, for example, mutedin, and then you can provide all the different operations that you want to do in one atomic batch, right? So first you say, on my document ID, which is in the variable ID here, I want to insert an attribute with some value. I want to remove the field name, and I want to replace the owner field with this new object here, and then I execute the whole thing, right? So in one atomic step, we are performing 3 SubDocument operations. Previously, what you would have to do is you would have to load the document, then you would change it on the server, like on your application side, and then you would store it back with the replace operation and give it the cas value, the compare and swap value that you got from the get operation to handle optimistic concurrency, because what you don't want is someone modifying the same document at the same time, and then you get data loss, right, if you're not careful. With this, you completely avoid all of that since it's in one atomic operation on the server side, and you don't need to deal with optimistic concurrency at all. And then for lookupin, what you can do is you can either fetch specific fields out of your document, or you can check if they exist. So here, what the lookupin will do is it will get you 2 fields, type and name, and it will return you true and false if the field with the name sum exists in the document. All right, let's move on to views. Views have been in Couchbase Server since Couchbase Server 2.0. And what they basically do is they do distributed map reduce, right? So if you store JSON documents, you can define your map function and an optional reduce function, which will emit document information in a B tree, and then at query time, it will do scatter gather similar to full text search, and then aggregate the results back and then stream it back to the SDK, which will then of course give it to your application. It's really great for fast aggregations and those kind of things where you want to group results. Like for example, you have some temporal data sets where you want to group by year, month, day, and so forth. Doing those kind of aggregations are very efficient and fast when you do this with views. We also have geospatial support, so you can create spatial views, so you can do all kinds of spatial lookups there. Now, views have been in the system long before Nickel came along, right? So for many use cases, Nickel superseded views, but still there are very interesting use cases to use views as well. So how can we query a view from .NET, for example? We create a view query object, and then with the from parameter, we give it a design document name. A design document is a group of views, and then we give it the name of the view. So here our view name is by name, and then we also apply some params like limit. So we say only give me the first 10 records, right, and then stop doing it. And then we execute with giving the query to our query method in the bucket, and then we get our rows back, and then we iterate over those rows. And the Java code looks very similar, and then in other languages like .NET, you'd get a callback and so forth, right? But the approach is always the same. Nickel. That's one of the pieces that you've probably heard a lot at this conference already. So just briefly touching on it, it's a little more flexible because you get the expressiveness of the Nickel query language. But the important part here is get your index right, because if you don't get your index right, then the performance is a little undeterministic, right? Because the same query could take 5 seconds or it could take 10 milliseconds, depending on the way you configured your index, which is not really part of the application you write, but then it's up to the server to have the correct index installed. And also a difference is that it's a global index compared to views, which is doing MapReduce, right? So in the background, the query engine will go to one specific node where the index is, will ask the index for its data, and then on demand fetch the documents over Keyvalue. So there is some indirection involved, and we'll see later a little bit how we can optimize it even from the SDKs. So how can we execute a Nickel query? And this is very similar to a view query, not by accident. Now, what we see here is this is the Go SDK executing a Nickel query. So the first thing you'll see is it says new Nickel query and execute Nickel query. And if we go back here to .NET, we'll see just the query method. Now the reason is Go doesn't support function overloading, right? So while in .NET and Java, we have one query method which gets overloaded with all the different queries, views and Nickel and full text search and so forth. In Go, there are different methods just for each argument. But you can still guess that this is pretty much the same, right? So we create a new Nickel query, and then we execute it, and then again, we iterate over the rows as they come back from the server. So pretty straightforward. Full text search. I would say it's nearly in the same category as Nickel in terms of latency and flexibility. It's just a different way of querying. And who has been in the full text search talk right before the session? Quite a few, great. So as you've seen there probably, the thing is that they're very flexible, but it's also a little more intimidating up front to learn all those concepts, right? Because as Marty pointed out, you can start out and create an index just by saying, create an index and do whatever you want. But then you get this huge index which indexes everything, and then suddenly you add a field to a document, and suddenly your index blows up to gigabytes of data, right? So you need to learn basically what is a tokenizer, what kind of stemming do I use, right? Do I need to pick a language? Should I only index specific fields of my document? But if you do that, then you get a very powerful full text indexing engine. I want to point out that, of course, this is still a developer preview. For the next major release after 4.6, this is planned to go GA. And if you are coming from Elasticsearch, it's very similar to that. And I would argue, actually, that our API from the SDKs is much easier to use as the Elasticsearch one, because the Elasticsearch API and also our full text search in JSON API underneath is very complex. So if you've looked at such a query, like especially if you do like nested queries where you combine them with must and must not and so forth. So you get this huge nested structure, and doing this either via HTTP or using like the Elasticsearch client is sometimes a little complex and tedious. But we really try to abstract all this away from you and make it as similar as possible to Nickel and Fuse. And as you can see here, so what we do is in .NET again, instead of creating a Nickel query or a Fuse query, you just create a search query. You provided, like here we do a phrase query, so we are looking for the phrase in the field name, so we're just looking for a specific phrase in a specific field, and then we give it the index name, and that's all we need to do. We pass it to a query method, and then we can apply some optional parameters like skipping and limit and providing a custom timeout, so you can all of that here. And then we give it to the query method, and we iterate our rows, right? So you can see, even if we have all those complex different services on the server side, the SDKs abstracted away from you and give you a unified interface, right? All right, quick note about analytics. So I think actually at this slot, so sorry, you would have to watch it, the recording afterwards. They are giving an in-depth review of the analytics service. You should check that out online because I think it's really interesting. But thanks for coming anyways. So it's similar to Nickel for querying in terms of the APIs. It's using SQL++, which is very similar to Nickel. And it performs great on huge data sets, right? So basically, its sweet spot starts there where Nickel stops, right? So you get all this flexibility. We announced the developer preview here at Connect. Unfortunately, I can't provide you some code examples yet because we are still trying to figure out how we make that all work, integrated into the SDKs. So if you come back next year or check our blogs on a regular basis, sooner or later you'll find news how we're integrating that into the SDKs. Finally, I want to mention one other service, and now we are moving our ring way to the left again, going to low latency, is the streams and changes feed. Now, our TCP protocol. While this is not the primary interface that most people interact with, we have lots of demand and ask for, can we get some kind of changes feed? And the answer is, maybe. And the reason is that our TCP protocol is internal, right? So it's not meant to be publicly consumed because it's complex, right? Doing streaming in a distributed system has lots of edge cases and things you don't think about when you prototype applications. Stuff like rollback, right, is something that's very hard to handle. So I briefly wanted to mention is that we are developing a TCP client in Java and in Go. So we have clients available which we then use to build high-level abstractions. So if you're interested in that, I recommend you to check out our Spark connector and the Kafka connector, which build on those low-level primitives, right? And then give you the higher-level APIs that you actually want to consume. Now, if you have a very specific custom use case and you really want to use this, go talk to me afterwards and we'll figure something out. But don't start right away here at the lowest level. Start with Spark and Kafka and all those connectors that we provide that build on those fundamental abstractions. And then if you need to go lower level, you can consider that as well. Now, we have all those different services, but I want to give you a guideline. So here is Michael's super sophisticated flowchart to success. Like which service you want to pick. And of course, this is my opinion, right? So if you have different opinions, please make your own flowchart. But so in my opinion, if you know the document ID, use Keyvalue, right? So that's hands down. If you know how to get the document, and previously we would have said, okay, but if you only need some parts of the document, you could use Nickel, but now with SubDocument in 4.5, you can actually use KV to only fetch some parts of the document and get both the quick lookup performance and reduce the network overhead, right? What if we don't know the document ID? If you're looking for pre-grouped aggregation, so if you have an aggregation problem, right, where you can create your aggregation query up front, right? We can build those indexes in terms of Fuse. Then using Fuse is a great way. Do you need full text queries? Do you really want to query on like doing phrase matching, doing boosting, those kinds of things, right? Do you have freeform text that you want to query in some way? Use full text search. And for everything else, there's Nickel. So if those use cases don't work for you, then you can use Nickel to get all the flexibility you want on those complex queries, join data together, get crazy creating those kinds of Nickel statements, right? This is where Nickel excels. And I don't have analytics yet on the picture, but you can imagine that we could have added another one here saying, if you don't know what to use and your data set is huge, right, and you're not expecting a query in 2 milliseconds, but a few seconds are fine, and you want to mine gigabytes of data, then you want to use analytics, right? All right. So I want to close out a little bit with the not so dirty tricks for fun and profit. And what I mean by that is using the SDKs to use specific services is fine, but basically harnessing the power of the SDKs, we can actually build features or give you the flexibility to get more powerful things done instead of just querying those services alone. And let's talk through a few patterns that I came up with in terms of naming. So the first one is cache it while it's hot. And the idea is that imagine you're running a nickel query or full text search query, which potentially takes a few seconds. But you know that the underlying data is actually not changing. So what you can do is, and this is using the Java SDK now with our RX Java stuff, so doing completely asynchronous computations. This is all asynchronous. Is that we can do our query, and if our query returns, we store the document in a cache document, and then we look up that cache document. And if the document is gone, then we transparently go back to the query, right? So we can build basically a read-through caching system transparently with the SDK, right? So we're using nickel and KV together, or fuse and fuse and KV together, or full text search, to build this very simply in a few lines actually. So the first thing we'll do is we call get on our bucket. So we fetch a document which is called result cache. Now you can imagine what you could also do is, let's say if you want to have a cache for every query that you run, you could just basically hash your nickel query and use that as a document ID to get some kind of unique cache document per query that you're running. And we are grabbing our document from the server, and we have some metadata with our document, right? There is the document ID, there is the cache value, and so forth. But in our case, we just care about the content. So we use the map function to extract the content out of the document we got back. So that's fine, right? That's how we would quickly look up the document from the server. But what if it doesn't exist? Well, if we don't get anything back, and this is the switch if empty that you see here, if we don't get a document back, then we run our expensive query, okay? So how can we run our expensive query? So the first thing we'll do is we call .query on our bucket, and then we pass it on nickel query. And as you can see here, this is very similar to .NET, as you've seen before. So we call bucket.query, we give it our nickel query, select star from whatever, right? So this is up to you. And then we use flatmap. And what flatmap does in an RX Java context, it's basically mapping from one type to another. But here our other type is actually another observable. So don't worry about all the details. This is just to illustrate it. What's going on here is that we are extracting the rows from our nickel query, right, as they come along. So we are extracting the data, and then we are extracting the value. So what we end up with is the same, so basically one value per row that's coming back from our nickel query. But then, of course, what we need to do is we need to create our cache document. Because if we just do the query, our document would never be created. So what we do is we use flatmap again to call upsert on our database and say, okay, for every basically result that comes back from nickel, we will create our result cache document with a time to live of 10 seconds. So what this will do is it will create the document, and then it will live on the server side for 10 seconds, and then it will vanish. So what this will do is automatically, transparently, when you run a code here, for 10 seconds you will get the cache response, and after 10 seconds it will go away, you will do another nickel query, and then you would get the cache again, right? And if you expose this as an API to your users, you have built basically a cache for a probably expensive query lookup in, like 15 lines of code, right? So using SDK primitives, we can combine different services on the server side to provide additional functionality, which is pretty powerful. So here's another one. This was the custom bulk loader, right? So what we can do is we can perform a nickel FTS of view query to just fetch the document ID and then perform a bulk KV fetch. Now, why is this even? Why do we need this, right? Can we just do select star from and get the full documents back? Well, if you think about it, how it works under the covers, the nickel, the SDK sends a query to the query engine, which is doing the nickel parsing, right? It's doing the indexing analysis, it's figuring out the right indexer. The indexer returns the number of the document IDs, and then internally, what nickel will do with the query engine, it will go and use the KV system as well and fetch the documents that it needs, and then it will stream it back to you from the server side. Now, this is just adding one level of indirection, because using our SDK, we can perform the KV fetches directly, right? So what we can do is to get increased performance, we can use select meta ID. So what this will do is we're not fetching the full documents from Nickel, we're just fetching the document ID. And the cool thing about this is the document ID is always part of our index, so it's always covered, which means that it never needs to do a KV lookup in the background. And if you combine it with our memory optimized indexes, the Nickel query will return very quickly. And then we get the document IDs from the documents that we match, and then we use our get method on our SDK. And here, because it's all asynchronous and parallel, we will fan out to all of the nodes in the clusters and fetch the documents as they arrive. So imagine this would match like 50 rows, right? So we would get 50 document IDs. And what this code will do is it will perform those 50 get operations in parallel, going to all the nodes in our cluster, and then collect them as they come back and then return it, right? So instead of having one pipeline from Nickel streaming those 50 records back to us, we fan out to all of the nodes in the clusters and get increased parallelism, right? But it's not much more complex. It's just 3 or 4 more rows. We get automatically covered index, and we get high performance Keyvalue lookup by combining those two services together, right? Now, here's the same thing for full text search. So here we had our Nickel query, but the same thing works for full text search as well. And for those who've been in the full text search talk before, by default, we're not storing the document content as part of the full text search index because it's wasteful, right? Because the same content would end up both on the primary KV store as documents and in the index. So what we can do, of course, we can configure our full text search index to contain the content, but we can also use the query, very similar to Nickel before, to actually fetch the document. So here we are performing a search query. We are searching for the word Austria in our full text search index. And then we extract the hits. So the full text search engine returns us the hits that match. And then we feed it directly into our get method, and in parallel, again, fetch documents from the server side, right? So this is a great way, again, to create a small full text search index, get fast indexing access, and then performing the KV fetches in parallel on the SDK side, getting increased performance. And then here we have the Tarzan of the docs, which is the classical indirect lookup pattern, right? So, but I really like this approach. Now, we used to do this much more in the past when we only had Keyvalue access, because then you had to get creative, how you get from one document by its key to another document. So you would create another level of indirection. Now with Nickel, you could just do a join, right? But it turns out for lots of use cases, doing it by KV directly gives you much better performance while not having to trade off flexibility. And in some cases, it's even more flexible. Let me explain. So in this case, we are connecting to our travel sample dataset, and we are loading a route. So we are loading the route 10,000, and what we want to do is we want to get the airline for our route. Now we could use Nickel to basically fetch route and then join it with our airline document to get information, or we just do one get operation, we get the document back, here we're loading the full document. But imagine we could use SubDoc to be even more network efficient, to just fetch the specific key that denotes the document ID of the airline document, right? So we can fetch that, and then we extract the airline ID out of our document, and then we perform another get operation, right? So in 3 lines of code, we fetched one document, we extracted the content, and then we fetched the second document. Now, this is a simplistic case, but you can imagine what it can do is you can create like user-defined functions, because what this allows you to do is add much more sophisticated knowledge in between. You can fetch a document, and then maybe you need to go to another, like a web service or something, right? Let's say you're building a microservice application, right? So you fetch the airline ID, then you go to another microservice, fetch more information, which allows you to construct another document ID based on this information, and then go again to Couchbase to fetch the documents, right? So you can, because in Nickel you are limited to what you have available in terms of API, right? So there's the Nickel syntax, that's it. But here you have your full programming language at hand, right? To build custom-built logic, and then rely on Keyvalue to get the best performance when you really want to deal with low latency. And then of course feel free to combine that with another lookup to Nickel or whatever you want to do, right? So you're completely free in which queries you want to do. So let me close out with a quick summary. So hopefully what I wanted you to take away with is that when you're looking at the different services on the server side, right, and the SDK APIs, the key takeaway is that first you need to decide what are my trade-offs, right? Do I really care about low latency? If you want the lowest latency possible, you need to go KV. Or maybe that's not so much what I want, but I really want the most flexibility. Then maybe go look at Nickel, right, and analytics and so forth. And as we've seen before, we can combine that, right, depending on the use case. If you're unsure, maybe look at my success flowchart and pick the right one. But I'm pretty sure it's not that hard to figure out. And then also remember, there are powerful patterns. Don't just use the services alone. Get creative and combine the services to give you even more functionality, right? That's a great way to both enhance your application and to make more use of Couchbase Server in general. And the cool thing is the SDK abstracts it away from you, right? So you can develop all of that on one node on your development machine, and then you deploy it to 50-node cluster with MDS setup, 20 data nodes, 10 query nodes, and it will work, right? That's the nice thing about Couchbase and how you can deploy it. And finally, even if you are not going to participate in the first place, I really recommend you to check out our RFCs. If you want to see what we're up to, what we're developing next, right? And it's an opportunity for you to give feedback because let's say we're now starting working on the analytics API and you have some very specific things you want to see there. That's your chance to get in touch with us and then we'll work together to give, ultimately, because that's what we want to do, right? We want to give you the best API to make the job for you as easy as possible, right? So if you're not thinking about all of that I told you right now, then I think we did a great job. And if not, let us know. We are all around here the rest of the day and also reachable via internet, email, and so forth. Let us know if we did something wrong or if you like our SDKs. And thank you very much. And I'm happy to take questions if there are any. Yes? I think we got a mic.
So if you use Nickel with the use key statement or hint, would it be comparable to KV?
So you mean the Nickel use keys statement? Yeah, so to rephrase, so in Nickel there is a way to specify specific keys. So if you say select specific params from and then use keys and then basically give it an array of document IDs, you can select parts of it. I would say if you don't have more specific requirements, because you can build very complex Nickel queries still with use keys. But if it's really just about select foo bar from use keys, then just go use SubDoc directly.
Yeah, I do have a follow-up question. So I was trying to operate on one element of an array within a document. So I have an option to use SubDoc or use Nickel. But then if you use Nickel, you have additional advantage of filtering on the array to find your index and then mutate the element on that index. But with SubDoc, it looks like SubDoc doesn't allow you to filter on the array to find your element. So it looks like you have to load the whole array, find the element, and then mutate that element.
Yes, so if you are on SubDoc, what you can do is you can load the full array of one specific key. That's true, yeah. So if you need to be more flexible into the specific array part of the document, then you probably want to go with Nickel. If you want to load the full array, then you would use SubDoc directly.
Yeah, so is it better to use Nickel in that case? You mutate one array element using Nickel with use key, and then use the array function in Nickel to filter out the element you want and mutate it directly.
Let me think through that. So I don't know if I understood it correctly. So you want to use SubDoc, or you want to fetch the full array and then manipulate parts of it?
So I have an array with 1,000 elements.
Okay.
For assumption, I want to mutate a specific element with this ID. So I would first need to find out what's the index of the element I want to mutate based on the ID.
In this case, if you have that complex requirement, I would say maybe you can go with Nickel directly because it can do it in one shot. Okay. You would have to probably benchmark the overhead, but especially if it's a large array. Of course you can figure out the index and then update it, but that's an edge case where you'd have to see which one is more performant. You can definitely do both, right? So you can get the index, but one thing you need to keep in mind is that if you do two operations, it's not atomic anymore, right? Imagine someone is pushing to that array at the same time you're doing lookup, then you probably have an outdated index.
Yeah,
right? So that's something to keep in mind as well.
Yeah, I think that's another reason we went with Nico for that. But last question.
What you can still do is you get the cas value, right?
Okay.
And when you do a subdocument mutate, you can always pass the cas value to make sure, like you can do optimistic concurrency on the subdocument part. So it will only mutate if the document hasn't changed. So there are ways to work around it.
Yeah, but cas value is on the whole document. It's not on the
Yeah,
array.
but it still works even if you do subdoc. Because what happens on the server side, even if you do subdocument manipulation, it will end up changing the full document on the server side.
And if you Nico with use key, does it fetch the whole document or does it just?
Internally, yeah. That's just not exposed to you. But Nickel internally right now is not using subdoc.
Thanks.
But they will probably change in the next version since it's an implementation detail.
I have a little bit more of an organizational question. So, when transitioning from a standard enterprise RDBMS MS environment where you have, siloed responsibilities, where you have developers developing Java code, you have data architects that are helping with like the indexing and a proper performance on the database side. Just from this presentation, it sounds like those traditional differentiations between skill sets is being eliminated, that your developer is responsible for understanding how to index and how to properly query data, a lot of decision making in terms of like how to develop the code to get optimal performance. So I guess the two questions is, what do the team compositions look like when developing against in an enterprise environment? What do the team compositions look like? And the second, what would I need to expect as a manager, the ramp up time from zero to being able to efficiently develop in a Couchbase environment for a Java developer that's only historically developed against RDBMS?
Okay, thanks. So let's start with the ramp up first, right? So, one thing that we see is that, especially if you're coming from an RDBMS, picking up Nickel is very similar, right? Because then you still have this traditional separation of, you write one Nickel query, which is like a SQL query, and then the operations guys are responsible for creating the right index so that the query performs fast, right? So that's very similar to a traditional SQL system. I think it depends on the use case, but in general what we've seen is that if you start from that, it's fine, but very quickly you should investigate and see, is that still the best way to deal with from a Couchbase perspective? Or is it just we migrated our SQL statements over to Couchbase? Because then the question is, do we get the best out of Couchbase in the first place, right? Because why are you migrating? Maybe you're not, there must be some reasons why you're not sticking on your traditional relational database, right? Is it scalability? Is it the schema, like the lack of flexible schema and so forth, right? And if you, for example, find out that actually we get better performance, and then you can see maybe there is one specific use case, we can break that out and then figure out how we can optimize it over Keyvalue, for example, right? And that ties into the question of like, what skill set do you need have as a developer? And I always found it a little strange or a little fallacy that as a developer, I said, let the ops guys figure out how it works, right? It's a little like sitting in a race car and the race driver says, my mechanics already know how my car works, right? I just push the brakes and the gas and it will work, right? Because as a developer, you need to know how the thing works you're developing against, right? Even if I develop against a traditional SQL database, ideally, I know how it works so I can get out the best performance, right? And this also ties into DevOps, right? Nowadays, developers, they push to Jenkins and then they do all kinds of stuff with Docker and they deploy the stuff on their own. So I would say, if you're in a traditional enterprise context and you're coming from SQL, probably going to Nickel first will give you the lowest barrier of entry, I would say, right? So the semantics are very similar. You can still have your ops team optimizing the index. But then from there, I would basically start ramping up into the other services that Couchbase provides and see how I can get additional benefit. And maybe sometimes that's not even possible right away, right? Because sometimes you're switching because of a very specific need. I don't know, we can't do this over SQL because it's too slow, and then you probably are forced to look at KV in the first place, right? So, but that's just very generic advice, at least what I've seen. And But you're right, definitely. So if your developers come to a technology like Couchbase, they need to have more knowledge of what's going on the server side to get the best out of it, I think, right? I mean, you can treat it like a black box in many ways, but if you know more about how we scale and distribute and like what performance or latency guarantees a nickel query has, how quickly can I do a KV query, right? Stuff like that. The more knowledge you have, the more power you can get out of the system, right? Does that answer the question, Lim?
Yeah, and like from 0 to competent, is that a 1 month, 6 month? What's the time frame?
If you let me know how talented your developers are. But the thing is, I mean, picking up nickel is very easy. And maybe I'm a little biased, but I think our SDKs are one of the best compared to other NoSQL databases, especially, for example, let's take Redis, right? Redis has 5 different Java SDKs, right? So you need to figure out which one to pick. And we try to be very consistent. So we have good documentation, I think. We improved quite a lot in that space. And I mean, how quickly you can ramp them up, I don't know, right? I mean, we do workshops, like we do full day workshops, and people start to build already all kinds of applications, right? So you can definitely ramp them up on the basics in a couple of days. But then when it gets to how to build robust production-grade applications with making sure you handle edge cases like node failures, right? What happens if that node goes down? How to properly retry? Do I need to add mechanisms that let me go to like another system in case a Couchbase server goes down and so forth, right? But there are other concerns that you would have in general if you're building against a distributed system, right? Because traditionally, working against one SQL server, there was no real option. If the SQL server is down, your system is not working anymore. But with a distributed system and modern technology, you have much more options available, which of course gives you more flexibility, but also maybe a higher learning curve, and you need to learn more technologies, right? So, all right. Then thanks very much again, and I'm happy to take questions in the hall and so forth. Thanks again. Oh, is there one more? Last one. Okay, there one more.
Hey, Michael. What's the current landscape of the SDK parity? I noticed you put, I think, 4 or 5 up there, but I didn't see like Ruby. I've heard rumors that there's a Rust SDK being brewed up somewhere. And I love the RFC, and I was just wondering if that RFC process is going to help keep things in parity.
I didn't pay him to ask the question about my new favorite toy language. That's fine. No, so we have a couple of the official ones, right? Go and Java and so forth. The Ruby one actually was official at some point, but for some reason, the lack of like people asking for new features, we decided to temporarily at least move it into a community state. So we are still like making sure people, if they run into issues, will help them, right? But of course, we need to draw the line somewhere and see with our limited manpower, right, how we can support those SDKs that are wanted the most, right? So Ruby, it still works, and we even got community contributions, someone picking it up and developing new features with it. Now, speaking of Rust, so there is, again, it's like a community module that developers like me develop on the side, right? There's no support for it, but it's built on libcouchbase, our C driver. So it works fairly well, but it's not an officially supported SDK at the moment. And in terms of parity, so the official supported SDKs, they all have feature parity. So that's what we are striving for with the RFC process. Making sure if we define a new feature, lay it out, prototype it in all of the applications, and then once we deploy it and we commit to the feature, which very often aligns with server features, right? And then they all have the same feature set. So if you go to Java and you get SubDoc, you get the same in .NET and Node.js and Go and so forth. All right. We need to wrap up. Thanks very much.